Hi everyone. Today we've got a derivative and a vertical asymptote question. So, consider the graph of the following function. F of x equals 16 over x plus x squared over 8 for x to not equal 0. So x cannot equal 0. Write down the equation of the vertical asymptote. So if you remember, an asymptote is just a point at which the function approaches, but it never quite gets to that point. So I think the easiest thing that we can do is graph it. So on your calculator, you go to the graph function. Now I've already put 2 in here, but you just need the blue one for this. So you can see 16 over x plus x squared over 8, and I'm going to draw that. And you can't quite see, so let's change the view window. Let's change this to negative 100 and positive 100. Exit and draw that again. Okay, and we can see, you can intuitively kind of see where the asymptote is, but let's be precise about it. So let's get our trace function, and let's just, you see where that pink little cursor is. I'm just going to go to the right, to the right, to the right. And now when x is 0, it says that the y value has an error. Then if I keep going to the right, now it's going to pop up on that other side. So you can see where the pink cursor is. I'm going to go left again, left, 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 left. And then it says that there's an error for when x is 0, y, there's an error. So that point doesn't exist. So the vertical asymptote for this particular equation is the equation when x equals 0. That's important. So for part A, the answer for this, it says write down the equation of the vertical asymptote. See, the equation is going to be x equals 0. That means that there's a that means that there's a vertical, let's get a different color. There's a vertical line right when x is 0. That's what that is telling us. So your answer for part A needs to be in that form of x equals 0. Otherwise, you're not going to get a mark for it. It's only worth 1 mark, and that is the mark. That's the mark that you get. So again, I think easiest thing is just get your calculator and draw it. Second part B, it says find the derivative. So for part B, if I just write this function down, I'm going to write the original function, but I don't like those denominators really. It's a bit confusing. So I'm going to bring the denominators up to the top. So 16 over x is the same thing as 16 times x to the power of negative 1. That's one of your index laws. And x squared over 8 is the same thing as 1 over 8 times x squared. I just like that a little bit better for when we're doing derivatives. Now I can take the derivative. So my notation needs to change. My next line is going to be, it's going to be my derivative. Now I can do my little rule with my derivatives where we take the power. Let me actually circle this. We take that power and we multiply it by the coefficient. So let's do that. Negative 1 times 16 is negative 16. And then we drop the power by 1. So from negative 1, we're dropping that by 1. So it's going to be negative 2. So x to the power of negative 2. And we can leave it like that for the time being. Then we're going to have plus, we're going to do the same thing with the power. We're going to take that power and we're going to multiply it by the coefficient out the front. So 2 times 1 over 8 is the same thing as 2 over 8. And 2 over 8 can be simplified down to 1 over 4. So 1 over 4, x to the power of 2 minus 1, which is just 1. So x to the power of 1 is the same thing as just x. Next line, this is still b that we're doing, is I just want to tidy this up a bit. So negative 16 over x squared. I've just taken that negative power and I've made it into a positive. Again, just tidying it up a little bit. And then we can simplify the second term to just be x over 4. Those are the same thing. 1 over 4 times x is the same thing as just x over 4. So that's part B. Part C, it says, write down the interval for which f of x is increasing. Well, I can go to my calculator, and I've already typed this in, but I'm going to type in my derivative. So the derivative that we just worked out from the previous question, I've just typed it in, and you can see on my calculator that's the red function. I'm going to select it, I'm going to draw it, and you can see the view window isn't great, so I'm going to change the view window. I'm going to just put negative 10 to positive 10 and see if that works. Exit, draw. Okay, and that's basically all we need for this. So the derivative, if we remember, the derivative tells us the gradient of the original function. So if the derivative is positive, that means that if it's in the positive y value, it means that the original function is increasing. So that is what we want to try and figure out. So how we do this, we press G-solve, you go to the next page, we want an x calculation, and we want y to be 0. If we figure out what x is when y is 0, let's see what it is. It says x is 4. So if you're looking on my graph on the calculator, anything to the right of x equals 4 is positive. That means that it's increasing. The original function is increasing after that point. So how do we write this as an interval? If we come back to the question, we know that it wanted it as an interval. There are a few acceptable answers for this. You could either write, and my preferred way of writing this is just x is greater than 4. So this is saying again that when x is greater than 4, the original function is increasing. And again, you can see that because the gradient is positive after that coordinate when x is 4. The other way that you could write it is you could write 4 is less than x, which is less than infinity. That's another way of writing it. Both would get answers, but you need to write it, you need to express it as an inequality. It's not equal to 4, by the way. That's an important factor. It's not x is greater than or equal to 4, because we know that when x is 4, the gradient is 0. That would be at a stationary point. So it can only be x is greater than 4.